Hey everyone, thank you very much for having me. I've been an AusNOG spectator since 2012 and I really appreciate the opportunity to be a contributor. So this presentation is about a carrier microwave network that we built in Central New South Wales. It was a very interesting project and I just wanted to take you through it. So a little bit of personal history. In 1998 I started a computer repair company. In 2004, started a wireless ISP. In 2017, that was bought by an MSP, and I contracted them for quite a few years. And in 2020, started a network construction company, which is what I do now. So I was contracting to the MSP, doing a telecommunications compliance project for their new acquisitions, and having a chat with one of the managers, and he mentioned that they had a mining client who had some comms issues. There was a 20 megabit connection into the mine for the whole site, so they had to service the admin, production facilities and the camp. And there was no ability to upgrade this network. So they're also accused by the local community of saturating the 3G network when all the miners rocked up into camp. So I suggested that they build a radio network to get some more capacity into the area. They agreed, and this presentation is about that project. So there are 3 sites located in central New South Wales. One's near the town of Keogh called the Peak Mine, and there are 2 more near the town of Nymagee called the Hera and the Federation Mine. They're about 8 hours northwest of Sydney in the Bogan Shire. So the Bogan Shire has an area of 14,000 square kilometres, about 2,600 people. It's mostly farming, a little bit of mining and a bit of tourism. So the main tourist attraction is the Big Bogan, located in Nyngan, and I was fortunate enough to visit it on one of my trips. So we wanted to get, so the requirements the requirements were to get more capacity into the mine, connectivity for the new Federation mine that they were building, boost the internet access for the camp and some of the remote offices, and get data connectivity between the 3 mines. And we're also asked to try and improve the mobile coverage of the area, of the Federation mine. So the solution we proposed was to build a high-capacity radio network, connect the 3 mines together, that's Peak, Hera and Federation, use their existing IP WAN for the corporate network, install a new gigabit internet service for public internet, rebuild the camp Wi-Fi and install some cell-fi relays. So this is the process that we followed, and this is pretty much the presentation. Topographic analysis, equipment selection, radio spectrum allocation, network design, power system design, staging, logistics, construction, rebuilding the camp Wi-Fi, mobile repeaters, did some security and surveillance networks, and set up network monitoring. So the first thing we did was perform a topographic analysis, and we used just basic radio design tools that are all sort of freely available. Cambium Link Planner is a great one, Radio Mobile, been around forever, and the Ubiquity ISP design product, which is what this demonstration is. So when you're building radio networks, typically you want direct site to site, short as possible. In this case, the link's obscured, so it's about 80 kilometres. We're blocked by the curvature of the Earth and a mountain. So to avoid the obstructions, you could make tall towers, 250 metres tall in this case, which is not feasible. Or you try and use the natural topography. So where an existing site exists, use that where possible. We actually found 2 essential energy sites on this path. One's located in a place called Canbelago, and the other one is on top of Mount Nymagee, which overlooks the 2 mines. So if we connect Keogh to Canbelago, Canbelago to Nymagee, and then we can connect from Mount Nymagee down into Hera, which is one of the mines, and Federation, which is one of the new ones that they were building. So that allows us to sort of extend the fibre capacity from the Peak mine, which is near Keogh and quite well connected, into the other 2 mines. So here's what the link path analysis looks like. We've got a link from Peak Mine to Mount Boppy, which is 38 Ks, Boppy to Nymagee, 53 Ks, Nymagee to Hera Vent Fan, which is the Hera Mine, 10 Ks, Dominion Hills, 21 Ks, Nymagee to Dominion Hill, Dominion Hill back to Hera Admin, 10 Ks, and then Dominion Hill down into the Federation mine site is 1.6 Ks. So this is what the whole network looks like end to end, all nice line of sight links from existing sites. And total of 7 radio sites, 9 radio links, and about 135 kilometres of distance. So next we needed to select the equipment. We chose the NEC iPasso Link products. They operate in licensed spectrum. They're carrier grade hardware. They do frequency division duplexing, which is important for the licensing regime. They have XPIC and lag for increased capacity. They also have dual DC power inputs for extra redundancy. They're split systems, so there's less radio gear up the tower, and they're also a modular design, so it's quite easily serviceable if there's a fault. You just pop the radio cards out or something. So next we needed to secure some radio spectrum. This is licensed through the ACMA, Australian Communication and Media Authority. It can be done directly, but it's not recommended. It's very complex. There's a lot of complex rules that need to be followed. So we use RF engineering consultants. It's way quicker, way easier. We've been dealing with spectrum engineering for about 12 years. So you do have to tell the RF engineering consultants what bands you want to use. The vendor can usually help with this sort of stuff, but as a general rule, long distances require low frequencies, and the more bandwidth you have, bandwidth in megahertz, then the higher capacity the links will be. So we used a mixture of 8, 11, and 80 gigahertz in this particular network, and we generally licensed 2 frequencies across each path. And this was done for redundancy and also capacity. So next we needed to arrange site access. Where the client owned the site, this is quite easy. I'll just let you on. Where another company owns the site, you typically need to get a site access license. And before the owner of the site will give you a site access license, they require you to do a structural engineering assessment. And that's for wind loading, for what equipment you're going to put up there, as well as the mount design. And also identification of where you're going to put the equipment in their compound or their hut and where you're going to get the power source from. So now we've got the sites identified, the equipment selected, radio spectrum allocated, site access coordinated, we can finalise the network design. So we created a ring topology. We use 2 separate radio chassis at each site. The only thing we share are the dishes, one using the vertical, the other using the horizontal polarity. There are minimal single points of failure. They only share passive devices, and all electronics are redundant because this is quite remote, this site. So we're able to sustain multiple faults and have the network remain operational. So the power systems, we powered each radio using 2 separate 48-volt power supplies. Each system provides backup power to the other. So power supply 1 supplies radio 1, backs up radio 2. Power supply 2 supplies radio 2 and backs up radio 1. And this also keeps the demand balanced. So we built 2 identical AC power backup systems for each site. They have a single AC source, whether that's the grid, diesel generator, or a gas turbine. There's 2 inverter chargers, 2 48-volt lithium battery banks, and 2 power rails. That's just standard AC power rails. So for devices without dual inputs, we added an automatic transfer switch. This basically senses the loss of power on the primary feed and switches to the secondary feed in about 20 milliseconds. We also had to design an off-grid power system. So there are kind of 3 distinct parts to that: the generation, the storage, and also the conversion from DC back to AC. The generation, we used a combination of wind, solar, and a diesel generator. The storage, we used 2 large lithium battery banks, as well as a diesel fuel tank underneath the generator. And then conversion was 2 3 kVA power inverters for the primary and secondary rails. So this diagram shows one half of the system. The whole thing is duplicated, with the exception of the wind turbine and the generator. The generator is capable of powering both systems, and the wind turbine we just connected to the primary. So the wind turbine keeps the system topped up overnight when it's windy, and the diesel generator is only used after long periods of really bad weather. So next was the staging process. We had a warehouse in Southport where all the stock was delivered. We built as much as possible in the warehouse before heading out to site, so we were close to suppliers, and also had good availability of trades, so like the aircon guy could drop round and the sparky and stuff. And we also could do comprehensive testing before taking all the equipment out to site. So we had a trailer built by a local fabricator. It's just an aluminium frame, insulated panelling for the walls and the roof, 2 air conditioners to keep the temperature regulated. We've got 2 dual battery banks. Each battery has a separate breaker that feeds into a bus bar, that feeds into another bus bar on the back of the wall for all the components. So this has got dual power inverters, dual solar controllers, isolators for everything, bus bars for the distribution. We've got the wind turbine controller on the left there, ATS and AC circuit breakers down the bottom. So we finished building it in the warehouse and we drove it out to site. That's Southport to Keogh, about 1,100 kilometres. Took me 14 hours at 80 kilometres an hour. We had a 4.5 tonne Pantech truck, 2 utes and 2 trailers. There was lots of rain, lots of mud, and we arrived on site and unloaded into a 40-foot shipping container. So that's to keep all the equipment dry and out of the weather, and we could just come in and grab it each day that we needed as we were building the sites. So this is the construction process. The first site we did was Peak. It has the fibre interconnections, so we could actually bring each site online as we progressed through the network build. So the equipment was installed on top of the winder head frame. A winder is actually a big tower that's used to lower people and equipment down into the mine, which is 750 metres deep. It's an underground mine. They have a goods crane on the top, so they actually hoisted our equipment up, and we only had to walk up with tools. And when we were at the top, we installed the 1.2 metre dish. We had to put some equipment in the existing cabinet. It was a sort of space constraints, so we added a telco air conditioner to it. There was lots of dust, lots of grease, and a lot of spiders up there. Next one was Mount Boppy. That was an essential energy site, lattice work tower, 50 metres high. So we mounted the dishes about halfway up. That was we had specifically engineered mounts. They were made by the local fabricator again. They're all aluminium. That makes them really strong and really light. We had to hand lift all those ones up because there was no cranes. They're quite corrosion resistant, but it's not really that necessary out there. Nothing really rusts too much. So that's a 1.2 metre dish facing west towards the Peak mine. You can see the two coaxial cables. They're inside Anaconda. Anaconda is actually a steel conduit that we put the coax cables in, and that prevents birds damaging them. There's also 2 radios on a diplexer. One operates through the horizontal and the other through the vertical polarity, so they can share the same dish. That's Shannon up on top of a tower, terminating the coaxial connectors before plugging it in. There's the equipment hut that we used. We used an indoor rack in this one. Sort of from top to bottom, we've got the 2 radio chassis, the dual 48-volt power supplies, we've got a PoE switch for the camera systems. We use MikroTik management routers for all the management layer. 2 power inverters, ATS. There's a battery management systems down there, and 2 5 kVA batteries. They provide a fair amount of backup power for that site. 2 system controllers. The blue ones, they're the Serbo GX devices. They upload all the system information about the power to the portal. Sorry. Next build was Mount Nymagee. That's a 15-metre pole, grid connected. It's a concrete monopole. It was actually a decommissioned police radio site. Apparently they don't need police out there anymore. 1.2 metre dish north of Mount Boppy. Facing north to Mount Boppy, that's a 53 kilometre hop. And then two 600mm dishes. One was facing down into the first mine, which is Hera, and the second across to Dominion Hill. So we installed some security cameras, 4G out-of-band routers at all these sites as well as an outdoor cabinet indoors. So we originally were going to do it outdoors, but there was space inside, so why not have 2 layers of protection? Next installation was the Hera vent fan. So that's a pole 12 metres high, runs off the same gas turbine as the rest of the mine. There's an existing dish there, that's the 20 megabit service. We installed a new mount just above to avoid the local trees. In this site we used an indoor half rack and an existing control room. So the control room provides all the ventilation systems for the underground mine. We actually later installed a 2.8 kilowatt solar array just for additional power redundancy after prolonged power outages. So next we did the Hera mine. That's just a shed roof, 12 metres high. The coax cables from the office to the shed roof to gain the extra height to get over the tailings dam. 2 radios on the back of that one. They were configured in XPIC, known as cross-polarisation. They use the same frequency on both the horizontal and the vertical planes simultaneously and allows you to get twice as much bandwidth. So this one's a 1.4 gigabit link, and that provides that sort of capacity between the 2 mines for service synchronisation. We've got 3G, 4G out of band as well, and this one we just put it in their server room, put our half rack in the server room. So this one's the Federation mine site. That's a new mine they're building, or they've done it now. It's a 7 metre pole that just runs off a diesel generator. This is us driving the pole to site from our storage yard to the mine site. So we had some local contractors helping us with all the civil works. They poured the concrete foundations for the pole and the cabinet, and we installed a steel pole, 2 600mm dishes facing the 1.6 kilometres up to Dominion Hill. They're 80 gigahertz radios, and they get 10 gigabits each. In this case, we use an outdoor cabinet outdoors. It's a standby power system, just runs off a diesel generator. It's got a built-in aircon, and we did a fibre handoff for the client. The last site was Dominion Hill. That was a hut, 4 metres high, combination of solar, wind, and a generator. I actually left this one to last because it's the most interesting site. The civil contractors built us a new road. They basically they bulldozed a dirt track up to the top of the hill. We just drove the trailer on site and parked it in position. We attached some large masts to the trailer on existing brackets, installed the antennas on the mast. The civil contractors poured some concrete pads for us to install a solar terrace. Concrete actually reaches 70% of its strength in 7 days. And so a week later, we were there installing the solar mounts. These were actually originally ground mounts where you would hammer them into the ground, but this hill's made out of rock, so that wasn't going to work very well. So we actually cut the legs off, welded some steel plates, and bolted them directly to the concrete slabs. So next we installed the solar panels. There are 32 360 watt panels across the 2 arrays, giving us a total system capacity of 11.5 kilowatts. We also have a 10 kVA generator. There's 2 10 amp single phase outlets. We use about 50% of the capacity of the generator, and it takes 13 hours to give the system a full charge if it's been raining for a week. So this is the finished site. We've got 4 cameras up there giving us 360-degree visibility. We put in a wind turbine as well, 750-watt wind turbine. Radio dishes. We had wind-down legs that we put on concrete pads. We also chained it to rocks. Basically, we wanted the trailer to stay level and prevent any unwanted movement, as that can knock the antenna alignment off. So we finished the power systems inside the hut with the power inverters and the solar chargers. Just an aerial photo of the site. And we finished the build just before the rain. So now we had more capacity or more bandwidth into the camp, we needed to upgrade their Wi-Fi. So the problem is dongas are little tiny tin boxes and they block Wi-Fi signal. So there are 136 rooms, 17 blocks, and there are 8 rooms per block. And each room has a window that looks out onto a common breezeway. So we installed a 60 gigahertz Cambium multi-point radio for the distribution network. This got about 500 megabits to each block. Then we installed the Cisco Meraki Wi-Fi access points in the walkways, and it allowed line of sight through the windows to each device. This is a photo of the Cambium distribution node installed on top of the rec room. It's connected directly into the fibre switch. We just installed the subscriber modules on tin mounts. We've got 2-on-1 mount to avoid that local tree. So the photo to the right is actually the high gain subscriber module. That's at 350 metres across to their core sheds, so the core shed guys can get on the enterprise network. So we just installed 2 small weatherproof enclosures on the side of the box, on the side of the dongas. Dual power outlets, just put the radio power supplies in the box and connected them with an Ethernet patch lead. We put the Cisco Wi-Fi access points in a weatherproof box as well, and that just provided additional protection against weather and tampering. The last part of the project was actually cell five, so mobile repeaters. So to get some mobile coverage at the Federation mine site, which had no coverage at all above ground. So there are 2 mobile transmitters in the local area. One's at the Hera camp, which is a Telstra 4G SAT-cow, which the mine paid for. And the other one is Mount Nemaji, which is a Telstra 3G, now 5G tower for the local area. So we relayed the signal via the Dominion Hill site down to the Federation mine. So we used Cell-Fi Go devices. They're authorised for use in Australia. They have dual carriers, so they can actually do 2 bands simultaneously, 3G, 4G or 5G. So the first one was the Telstra SAT-cow, cell on wheels. In this case, it's actually just a skid that they put on site. It transmits a 700 megahertz carrier frequency, band 28. It rate limits each handset to 2 megabits. So the centre photo is of the Yagi that picks up the signal from that SAT-cow about 10 kilometres away. And the second signal we picked up was from the Telstra tower at Mount Nemaji, which is 20 kilometres away. And they happen to be in exactly the same direction, so that's very handy. We then rebroadcast those signals using the panel antenna on the opposite side of the hut down into the mine site. So it's very important to keep good separation between the Yagi, so the Yagi and the panel, for the system to function properly. So we use different polarizations. The Yagi's vertical and the panel's horizontal. And the antenna's mounted on the opposite corners. So down in the Federation mine, we installed more relays, and this was to bring the mobile signal inside each office. So we installed a high-gain Yagi antenna on the roof, Cell-Fi relays inside the building with small paddle antennas for local coverage, and staff could now sit at their desks and use their mobile phones. So we achieved like a very high signal quality, signal strength, and antenna separation, which is what you want for these things to work well. The signal comes from the SAT-cow and the Telstra tower. We recently did a software upgrade on these, and now it relays a 5G signal, which is in the local area. There was now great coverage at the site for Telstra customers. I am not a Telstra customer. So the remote unmanned sites, we needed a sort of an extra layer of security. So we installed a network video recorder into the mine server room, remote IP cameras at each site, and we're able to stream this over the management network. So we can see people come and go. We can see our equipment on the towers and at the various sites. and we can watch and listen to the generator start up. That's probably one of the more useful things. See who's opening our cabinet, and do some pretty rudimentary image analysis, so we can detect when people come and go, vehicles, animals. Sometimes it detects people as animals and vice versa, and any other event that might be of interest. So all the power systems are Victron Energy. We use the Serbo GX controllers. This uploads all the system information to a Victron Energy portal and gives us sort of live visibility of the battery levels, of the production and the consumption. So this gives us a visual representation of one of the solar systems, the stats, the power flow, and also some historical trends, so we can see how they're performing. Network monitoring, I tend to use the dude. Gives me a really easy visual reference. Green is good, red is bad. Ease of administration, I can just launch tools, SSH, Winbox, web, really simple. So more detailed stats, I use PRTG. This just does SNMP queries on all the radios, gives me latency, receive strength signal, temperature, voltage, and allows me to sort of graph historical trends and pinpoint any of the root causes of outages. So changes in signal or voltage over time. And we can see if any antennas have moved. So this network, we have a maintenance agreement over the network. We monitor it 24/7, respond to any issues, and we go out on an annual basis for our preventative maintenance program. So thanks very much for listening.